All right, we're continuing our factoring. Here we're going to be factoring the difference of two squares. And when I think of the difference of two squares, I think of dots. So maybe you're familiar with this kind of candy, dots. Difference of two squares. Okay, only dots will factor. Never the sum of two squares. And we're going to talk about squares in a moment. But keep in mind, only dots factors, never sots. Dots is a candy that I would maybe consider eating. But if this had an S on it, that would say sots, and it almost sounds like socks. So that would not be a candy that I would be interested in. So whatever it takes to help you remember that the difference of two squares will always factor, but never the sum. All right, factoring the difference of two squares, you're really going to just reverse the special product for the sum and difference of two terms. So when I factor a squared minus b squared, notice a is a square and b is a square. And there's a subtraction in between, hence the difference. Okay? So when you subtract two things, you're finding the difference between them. That's always going to factor into two binomials where one has a plus sign and the other one has a minus sign. This will be a. Why? Because the square root of a is a, and the square root of b is b. And this is also a and b. So if we would do a FOIL, if we would multiply this out, a times a is a squared. This would be subtract ab and then add ab. See, they're opposites. Negative ab, positive ab, that would sum to 0. Positive times negative is negative. And then b times b is b squared. So we reverse the special product for the sum and difference of two terms. Here is the sum of two terms. Here is the difference of two terms. So just remember that when you have dots, you're going to get two binomials that are exactly the same, except the signs are different. All right, let's do an actual example. You have to look at the polynomial and ask yourself, are these two items that are separated by subtraction, are they squares? Well, x squared is a square. 36 is a square. 36 is 6 times 6. So how do I get my a and my b? You know, because this is going to factor as a plus b times a minus b. I have to figure out what my a value is. It's not too terribly difficult. Take the square root of each term. Remember, terms are separated by addition and subtraction. So here by subtraction, x squared is a term, 36 is a term. Take the square root of each term to get a and b. So if I look, you know, the square root of x squared is x. The square root of 36 is 6. So now I can take my a and my b and substitute. Remember, 1's plus 1's minus, and I use the x and the 6 both times. And if you do a FOIL with this, you're going to get the original problem. That's the beauty of math. You can check it. All right, the next one. I've got 16y squared subtract 81. Well, you have to ask yourself, are these squares? There's only two terms, and you have to know if they're squares or not. Is 16 a square? And you say, yes, 4 times 4 is 16. Is y squared a square? Yes, and remember, when we did all that work with radicals, this is why. It's important for square root stuff. All right, 81, is that a square? Yes, the square root of it is 9. The square root of 16y squared is 4y. So there's my a and my b value. So this is going to factor two polynomials where the a's are the same in each, the b's are the same in each. One is plus, one is minus. Okay, that's how we factor dots, the difference of two squares. D-O-T-S. All right, if you have any questions on this, you know what to do. Reach out on a Google Meet or on the homework discussion. All right, sometimes repeated factorization occurs, and you need to factor completely. Sometimes the directions tell you to factor completely, but not always. And even if it doesn't tell you to, you must. So you must factor completely. All right. So let's take a look at this. X to the power of 4 subtract 625. If you don't know if 625 is a square, which you should, because remember I wanted you to memorize 1 squared, 2 squared, 3 squared, all the way to 20, and then number 25. And had you memorize those math facts, you would know that the square root of 625 is 25. Recall from class and from video lessons that any even power on x is a square because it's divisible by 2. So x to the power of 4 is a square. 625 is a square. Take the square root of each. You're going to get x squared here, and you're going to get 25 here. I'm going to write my answer below instead of right next to. So this a would be x squared, so with that one. The b is 25. And this one's plus and this one's minus. But we're not finished. We still have dots here. Okay, so you have to keep going. It's kind of like, you know, when you would break a number down like 12 in a factor tree, right? Because we are factoring. 12 is 2 times 6. But we can't stop there. We didn't break it down to its prime factors. We've got to keep the 2, and the 6 can be broken down into 2 times 3. This would be the prime factors. So at this step here, we're like in the middle step over here. So we have to now take this x squared minus 25 because that is still the difference of two squares. We need to keep the x squared plus 25. It's part of the original product. And so now I'm going to take the x squared and the 25. Take the x squared and the 25, take the square root of each, and I get x and 5. So x here, 5 here, 5 here. One is plus, the other is minus. This is my final answer. Now, the sum of two squares never factors. I'll show you why. Let's first look at the difference of two squares. Let's do x squared minus 25. I could write x squared minus 25 as x squared plus 0x minus 25. And if I would factor this as a trinomial using the rules for signs, I would ask myself, what two numbers multiplied to 25 that when I subtract them give me a 0? Well, that would be 5 and 5. X, 5, 5. Because 5 times 5 is 25, and when I subtract these two, I do get a 0. This tells me the signs are different. One's plus, one's minus. Okay, so that's the proof. X squared plus 25. Well, I could do the same thing. I could write it as x squared plus 0x plus 25. Now I'm going to write my two binomials. I'm going to ask myself, what two numbers multiply to 25 that when I add them give me a 0? The signs are the same. They're both plus. That's not going to work. The only way to get 25 is 1 times 25 or 5 times 5. And if I'm adding 1 and 25, I get 26. That's not 0. And if I choose 5 times 5 and I add them, I get 10, not 0. So this never works. Suts, sum of two squares, is prime. It can never be factored. Never, never, never. All right, if you have questions, please ask. Remember, it's so important and very crucial in Algebra 2 that you really do learn factoring. So if you are struggling, then please reach out and ask for help. All right. Next on the agenda is another special type of polynomial called a perfect square trinomial. In the perfect square trinomial, the leader and the ender here, they're both squares. This is not dots, so it's not going to factor as the product of the sum and difference of terms. But this is the reverse of squaring a binomial. So what happens then is you're going to get a single binomial to the power of 2 because they're both exactly the same. And if the sign in the middle is plus, the sign in the middle here is plus. If the sign in the middle is minus, then the sign in the middle of the squared binomial is also minus. All right, let's take a look. Factor the perfect square trinomials. I need two numbers that multiply to 100. Then when I add them, give me a 20. Well, I know 10 times 10 is 100. Okay? 10 times 10. And when I add 10 and 10, I get 20. This means the signs are the same. And I'm going to add products. This tells me that the signs are both plus. All right, so I'm going to set up. I'm going to say, well, we already said 10 times 10, and this is a 1, so that's going to be 1x, 10, 10, signs are the same, they're both plus. Now notice, we have two that are exactly the same, and so you must write it as a single binomial squared. Trust me, there's a method to my madness for me making you do that. It's going to lend itself into another lesson in the future. So please, anytime you have x plus 10 times x plus 10 or x minus 3 times x minus 3, please write it as one single quantity to the second power, right? Powers or exponents indicate repeated multiplication. All right. Letter B, example B. You have to look at this and say, well, you could say, what two numbers multiply to 64 to add to 16? You should see right away 8 times 8. Or just say, is that a square? Is that a square? 99% of the time, these are perfect square trinomials, but not always. So be cognizant of that. You do want to do the check. 8 times 8 is 64. 8 plus 8 is 16. Signs are the same. They're both negative. So I'm going to get x, 8, 8, same signs, both minus. Oh, I've got two of the same, so I clean it up and write it as one of those to the power of 2. Why don't you try the last one? Pause the video and actually try the last one on your own. Okay, hopefully you pause the video. Now this one's got a 36 in the front. So we couldn't really do that, like the last one with the 8 times 8 is 64, and when I add them, I get 16. Because I have this to contend with. So hopefully you picked up on that. 49 is a square. So I want to know, and I'm going to try. And if I make a mistake, so what? I could erase it. 6x, the square root of 36x squared is 6x. So I'm going to put 6x there and 6x there. 49, the square root of it is 7. Signs are the same, they're both plus. Now I want to check with a FOIL. 6x times 6x is 36x squared. This here, 7 times 6, is going to be the same as this 7 times 6. That's 42 plus 42. 42 plus 42 is 84. So that works. And 7 times 7 is 49. It works. And since I have two that are exactly the same, I'm going to write it as a single binomial raised to the power of 2. Okay, so again, if you have any questions, post on the homework discussion. You know, I could make short little mini videos if you're having an issue with a homework problem. Just reach out to me and ask. But post it on the homework discussion so everyone has access to it. And if not, come to a Google Meet. I'm not sure how the meets are going to be run when you are remote learning. I may require you to be there on certain days. So keep a lookout for the announcements on the Schoology page. Okay, remember, if you have a puzzle worksheet, you need to write the problems on lined paper and submit for homework. Make sure that you're numbering the problems, and also make sure that you're putting your name on the paper. And one last thing, make sure you're putting the name of the worksheet on your homework so I know what I'm looking at. Alrighty, have a great day.